Let's briefly go over how we work with our exponent rules. There are several, and these are the big ones that we're going to see over and over again, especially if you're going to be moving into pre-calculus, calculus, and so on. We're going to start with the product rule. The product rule is when you have two expressions being multiplied and those expressions have exponents, those exponents are going to add up. Okay. So notice that we have the 3 and the 6, and notice that we add those to get 9. Whereas the normal stuff, right, the stuff that is not the exponent just continues to multiply as you would normally multiply. Okay. So we'll just do these two examples here briefly to kind of show you what that's going to look like. So here we have 8x squared times 3x cubed. So we're going to have 8 times 3x to the power of 2 plus 3. So we're going to have 24x to the fifth. Okay, that's going to be important there. Make sure that you are adding those exponents when the expressions are multiplying. Now, the same thing applies if you have multiple variables. You're going to combine like variables. So in this case, we want to combine the 2 and the 3, and we want to combine the 4 and the 5. Okay, so we're going to have x to the fifth times y to the ninth. Okay, and that would be your final answer. There's nothing else you can do. Now, similar to the product rule, we also have the quotient rule. We remember quotient as being part of division. So now when two expressions are being divided with their exponents, those exponents are going to subtract, right? Math's all about balance and opposites. And so really those two go hand in hand. If you're dividing, subtract your exponents. If you are multiplying, add your exponents. So you'll notice here that we have 6 and 2 get divided and we'll get 3, whereas 5 and 3 are subtracted, and we're left with a 2. Let's go ahead and practice that with this problem here. Oops, there we go. Okay, so again, the values that are not exponents are going to just divide like they usually would. So we would have 7x, and then we're going to take 5 minus 3 and have 7x squared. Okay. Similar to the product rule, if we have multiple variables, we still treat that the same, just combine like variables. 4 divided by 1 is just going to be 4. Then we have x to the fourth divided by x cubed. That's just going to leave us a single x. And then we have y to the fifth and y squared, which will be y cubed. Okay, that's all you can do there. Let's move on. We also have the power rule. So the power rule is when you have an exponent and parentheses with another exponent. So you are essentially going to multiply those, okay? Now, don't forget that the power is going to go to everything, including the number that is not an exponent. So notice that we have a 64 because that's 4 cubed. Whereas here, we did multiply the 2 times the 3 outside to get us a power of 6. Don't forget to distribute that power everywhere inside the parentheses. Let's take a look at this one here. Remember, we're going to go ahead and make sure everything gets distributed. So we have 5 cubed x to the sixth. So 5 cubed is going to be 5 times 5 times 5, or 125x to the sixth. Okay. Moving on to the next one. Now we have 3, which we will make sure to distribute to the 3, the 2, and the 4. So we're going to have 3 cubed, x to the sixth, and y to the 12th. 3 cubed is going to be 27, and then we'll bring down the rest. That's where you would stop. There's nothing else you can do there. Next, we have the negative exponent rule. So, generally speaking, in math, we don't love when we have negative exponents. We want to try to write them as positive values whenever possible. So, our main way to do that is to write it as its reciprocal. Okay. That means if we have x to the negative second power, we could rewrite it as a fraction with that value being the denominator, which makes the exponent positive. Okay. The opposite is also true. I'm going to go ahead and jump down to B to show you what I mean by opposite. So if you have a negative in the denominator, you could rewrite it in the numerator, right, over 1, which is redundant. So let me rewrite it like this. And that would make it a positive power of 3. Okay. The 2 is just there. The 2 has nothing to do with the negative exponent. So it stays on top. And we're just going to bring that x to the third power up with it. And that's what makes it positive. Now let me bounce back over here. This looks similar to our example from earlier. Again, the 3 is not the problem. It is the negative 5 that's the exponent of the x. So the 3 can stay put. The x to the power of 5 is now in the denominator, and that's how we can work with negative exponents. That covers the majority of the rules. The only other one that I don't have on here because we'll briefly chat about it, and it's something that you've probably already discussed, is the zero power. So anything to the power of 0 is always going to equal 1. So 2 to the 0 is 1, 10 to the 0 is 1. Everything to the power of 0 is going to equal 1. Otherwise, those are all the big rules you're going to see. Make sure you start to feel comfortable with those. They will be coming back over and over again.